Hi, I'm Chris. I'm the design engineer. So basically, I use two toy grabber hands, and they already mimic closing of a fist, but they would only close. The thumb would stay fixed, and the four fingers would come together. So what I did is I cut the fingers individually where they could bend by themselves, and then I cut a bigger hole out for the thumb and used a Dremel to make it bigger to where the thumb could go back and forth and not just be fixed in the position like the toy hands. So we used two hands because the thumb was fixed, so I stole one of the fingers from the other toy to make this bend, and then I used the extended arm to connect the Arduino, the circuits, and the hand all together. I used it as a mounting platform. I cut out rectangles for each servo motor. I ran the wires through there, and they come out the bottom here, and they loop around where you can plug it into your Arduino. It makes a good mounting base for the breadboard, and then I use the part that you normally grab your hand to mount the Arduino Uno, so it's all, you can move it, and you can take it wherever you need to go with it.
Perfect.
I'm gonna pass it off to Yanni.
How's it going? I'm Yanni Ritzes. I'm the coding engineer here. We're looking at the Arduino here to make sure how we have each servo pin connected with each output. So as you see here, we have each servo pin in its position and each output A0, A1, A2, A3, A4.
As it is here on the Arduino.
And as we see here, as you see here, it's connected between A0, A1, A2, A3, and A4. And then we come down here, and these are for the pin modes for each input and for each output. Basically, have each comment sending each servo pin to the output. But I did just in case it is, you know what I'm saying. Set each flex sensor pin to input. This is necessary because you need the input to have an output. And we come down here, and we have now the 400 to 700 scale. We had to adjust some to 500, 700 depending on sensitivities, and these are for the flex input for the position. And as you see here, pose 1 equals constrained pose 1 180 0. That is the position of the servo motors and how each of them are going to be adjusted. So as we input this code, as the flex sensor is flexed, the sensor now rotates 180 degrees in the opposite direction, and that is the code.
Beautiful.
Alright, so I'm Marcus and I'm the circuits lead. Pretty much what I'm going to explain is how we've connected the Arduino to the Elvis circuit board, and how we've connected the breadboard to the DC motors, to the servo motors, and the flex sensors. So pretty much what we did is, one, we pin moded everything like Yanni said in the code. What we have here is we have the power going through the full strip, so each servo motor is powered through that way. We also have the power connected here through two 10K ohm resistors because we needed 20 ohm resistance to convert the power we needed to have the optimal resistance. That way, when we do calibrate the sensitivity of the motors of the flex sensors, they actually work correctly. This one's not the one, but as you can see. And then we have the DC motor, the servo motors connected separately here, where we have the power to the DC to the servo motors, and they're also connected here to the Arduino at each pin, which was referenced in the code, so that they will fluctuate at 180 degrees per sensitivity of the flex sense.
Rock, paper, scissors, shoot.
Boom.
Scissors. Rock, beat.
Flex sensors.
Rocks, beat, scissors. Rock, paper, scissors, shoot.
Yeah.
Paper beats rock. There's flex sensors. Rock, paper, scissors, shoot. Okay, so here's scissors.
Scissors cuts paper.
Paper, and there's the flex sensors. Rock, paper, scissors, shoot.
Spider-Man.
Spider-Man beats scissors.
Yeah, Spidey senses.
Here's the flex sensor. Rock, paper, scissors, shoot.
Yeah.
Spider-Man and Rowdy. And the flex sensors.
4, 3, 2, 1, 0.
Go.
1, 2, 3, 4, 5.
Go.
Let's do 3. 3. All right, let's do 2. 2. That's 2. All right, let's do 4. And then we're gonna do 1.
Here's holding an empty water bottle. 1, 2, 3, 4, 5, 6,
Yeah.
7,
Yeah.
8, 9, 10.